Oh God.
I also occasionally get not English calls.
That happened once.
Not English calls happened once.
Yeah, like, someone called me, they left a voicemail, so I listened to the voicemail. It's either Chinese or some other strange language.
But yeah, okay. But anyway, remember when I talked about dynamic programming a while ago?
Yeah.
In the different random talks, where
Yes.
I had no idea what the fuck
Dynamic
was going
programming.
on.
Yeah.
It's a basic programming. It's a basic algorithm solving strategy.
Okay.
Alright?
Yeah.
And by basic, I mean, yeah, this is very basic.
Oh.
This is basic. If you want to have any sort of job anywhere, you might want to learn what this is.
Good job.
Nice shot. Nice shot, man. You're great at this video. You're great at this video. But yeah. Oh,
This video is great at you.
But yeah, basically dynamic programming is that you use sub-problems to solve other problems.
Huh.
You didn't learn this yet, or no?
If we have, it hasn't been by that name.
Okay, did you... So you know what greedy algorithms are, right?
Sort of.
Sort of.
Okay, then do you know what divide and conquer is?
I can probably infer what it is just from the name.
Okay, so then you probably haven't taken a
more.
formal class on it yet.
Probably not.
Like... Okay, Mario, you can stop running around in circles.
But this is
No, you
Mario.
can't. This is gravity. The only thing you're doing is running around in circles.
But random. His name's Run Man.
Run, man. What type of rip-off of...
Goodbye. Fuck
Kill
the shit, I'm
myself.
out.
You're becoming hysterical.
Mario, stop swinging. in
Hilarious.
circles. But yeah, it's a basic coding strategy to. You're on the thing.
It's invincible.
You use sub problems to solve problems. For example, if you're given a matrix, right,
Okay.
and the matrix can either have a 1 or a 0 in it.
Okay.
Right?
Alright.
Try to find the biggest square made out of ones.
Okay. That sounds interesting.
Like if you have
I'm not sure how I'd go about doing it.
Yeah, if
but-
you have no experience on what dynamic programming is, this thing would just be like, what? But once you know it, it's like, oh, once you know about it, or if you, like, even if you do know dynamic programming, it can be like difficult to wrap your head around. But like once you see it, or like once you listen to hear the answer, you can say, oh, I get it now, right?
Yeah.
I feel like that's the case for most things.
Yeah. So basically, the way to solve it is basically.
Complicated problems with very simple answers.
Yeah, so if you can imagine a square, right?
Okay.
So like the smallest possible square you can make is if there's
one.
one, right?
Yeah.
If there's one, right? That's a square size of 1, right?
Well, unless there aren't A1s at all.
Well, yeah. But that's if it's a 0, then there's just no square.
Yeah.
There's no square that exists in this plane of existence, right?
Yeah.
So like so we have the idea of 1 square, right? So then can we make a square size of 2 using all the 1 squares we have?
With just one of them being 1?
No, so we know what a square size 1 is, right?
Yeah.
It's just 1, right?
Okay,
So
so, we
what's
need
the-
to figure out whether we even have enough ones to make something bigger, right?
But yeah, something like that.
If we want a square
like-
size of 2, we'd need...
At least 3 more.
Well, I guess what counts as a square in this case?
Well, it's where 2 of them have the same size.
Okay, so
That's
it has to
exactly
be...
what a square is.
So it's like an actual square,
An
okay.
actual square, yes.
So in this case, square size of 2 would result in 4 ones.
4
Yes.
ones. 4 ones.
So 3 more than a size 1.
Yes. So if you already have 3 square sizes of 1, right? If you have the other one, you can make the square size of 2, right?
Yeah.
So then now, using square size of 2, how do you make a square size of 3?
Okay, so we'd want a 3x3 square, so it's just, we need 9 ones.
But how do you solve it in terms of 2s?
In terms of 2s?
Yes, because this is the recursive step in dynamic programming.
So we're
We'd
doing inductive /
probably need-
recursive reasoning.
It's inductive reasoning,
Like,
basically.
is
Yeah.
overlapping allowed?
Yes, obviously.
So we just
Okay.
need 4.
Yeah. So,
Yeah.
so you see a pattern.
This is gonna keep going. This is
Yeah,
recursive.
so you see the pattern, right? Once you have 4 of the previous size, you can make the
The next big
the
size,
next
which
bigger
is
one.
4 of those.
Right.
Okay.
So that is your recursive step. So basically, all you have to do, you make a matrix the size the same dimensions plus 1 on both edges of the previous matrix, right? Go through the matrix, right? If it's a 0 size, if it's a 0 or if I or j are 0, right? Like the first edges, right?
Yeah.
Then it's 0, right?
Okay.
When the first time you hit a 1, right?
You've got size 1.
Right. The first time you hit a 1, it's equal to the minimum of the previous one on the left, the previous one above it, and the previous one diagonally above to the left.
Okay.
Right? The min of all those values plus 1.
Okay.
And that's how it.
And then you store the largest number, right?
Okay.
And then that will always return the largest square of 1s in the matrix.
Okay.
So you got
So is it? Yeah, that's interesting.
yeah, so you see how it works now, right?
A little bit.
I find it endlessly fascinating and also incredibly important because that's basically half the interview questions what are gonna be.
Yeah.
Speaking of interviews question, I actually did a phone interview with a dude.
Oh?
Yeah. It was pretty weird. Well, not weird, because like when he did the phone interview, right, he asked me a couple questions about all the stuff I learned in the first year in freshman year of computer science.
Okay.
It's like, do you know what polymorphism is? And I'm like, oh no, we're doing this.
Good
Oh,
old
polymorphism.
polymorphism.
Yeah. And like, do you know what the pass by reference is? And like, oh no.
Oh no.
Oh no.
Oh, good old.
This is all the.
This is all just remembering what the hell the vocab means.
I remember all that stuff. It's like, oh no, it's all the easy shit. They're like, it's all the easy shit that everyone should know. I'm being vetted like a retard. They're treating me like an idiot. So obviously I get all those questions correct as I can get.
Yeah.
Yeah.
Okay.
I mean, that's to be expected of a random like you.
Yes. Like those aren't hard questions, okay?
Yeah, they're not.
If you've taken CS, if you slept through CS, you know. Alright?
Well, maybe not.
Maybe not.
Probably
But
not.
the general idea is that this is really stupid, easy shit that you should know. If you don't know it, then you're doing something wrong with your life and you should consider quitting CS as a profession. But yeah. We also talked. He also talked about trees for a bit, and,
Okay.
and like he like mentioned red black tree. I'm like, I know what that is! Yay!
Trees. Woo.
Trees.
Trees.
Can never get enough trees, which is great because there's a special type of tree that you can only find with dynamic programming. Oh, no.
Oh no.
I don't even remember what the answer is to it either. Basically, consider the idea of an optimal binary search tree, right?
Okay.
So basically, like binary search tree, let's self.
I've got to program one of those.
Yeah, it's like you got the ordinary binary search tree that is god awful when it becomes a single line. And
Yeah.
then you got the
then you got your self-balancing
self-balancing trees, which sort of mitigate it, but it's all right. Now consider a binary search tree with probability attached because
Oh no.
because
What?
in most cases when you use a binary tree, some indexes are going to be used more than others.
Oh, so
no.
it's got some caching now.
So now you have to consider.
no.
The probability of a word being searched, right? The order of all the words being in order correctly.
Oh, lovely.
Oh, that's terrible.
So you have to figure out how. So you're gonna have to figure out how to get the. How to make the most optimal binary search tree where the probability times the amount of times the depth of a node of a entry is minimized. I don't even remember the dynamic programming solution to that, so I can't even begin to tell you. Yes, please.
At least you have enough coins.
Yes. But yeah, very interesting.
Oh, it eats coins
Yes.
now.
Yeah, that's,
oh,
why
no.
that's why it has coins.
All the ones in Galaxy 2 eat coins.
That's weird.
What?
What is that?
It's a dung beetle ball. Oh, it's a boss fight. It's the dragon boss fight.
Hi!
Oh, hey, it's this thing.
Oh, he's got scars on his body now.
And he's also on fire.
Fire hot.
Hello, Mr. Man.
Mr. Man?
Oh, got him.
Wow.
Oh shit, right.
Remember, fire hot.
Fire hot. Fire hot.
Oh, I see.
I'm safe. I missed. Okay, got him. Alright, now phase 2! But yeah. Basically, the thing about computer science as a discipline is that after a while you start doing programming becomes less and less important. As opposed to the concepts.
Yeah.
Oh boy, the concepts. What did I even get? Oh, invisible things. Got it. Okay, touching his body that is on fire is absolutely okay.
When you're already on fire. At least.
There's no coins here.
There is.
There's only nodes. I can't even hit them. Okay.
See? You have to already be on fire.
Okay.
It's a boss. They tend to kill you.
No, they don't. Bosses are illegal. In my country.
What country are you from?
I missed.
Good job.
Oh, come on!
You are on fire. Fire hot.
Do those ever go away? They don't look like they go away.
Nope.
You're not gonna hit the.
I want to hit the last three. What? You can't do that.
Yes, he can.
I missed.
Fire hot.
What?
Dead.
What?
I'm gonna do an internet.
Whoa.
Whoa! God. Finals
even-
League was hectic as hell.
Huh?
Oh, come on! I just immediately get hit! Okay, screw you, video game. You can't catch me, I'm faster. Yep, there's another Shadow Bridge. 2, 3. Uh-oh. Okay. Apparently my cooldown is too slow to hit them in succession. There we go. There we go. Okay, so now...
Oh, I think it's more that you just got there too late.
Whatever. I can hardly give a damn. Ah, hey look, meteors! Hello, Mr. Dragonface! Oh, hello, Mr. Dragonface! Goodbye, Mr. Dragonface. I did not like to see your Dragon Fate. Please do dive bomb now. Eventually. Thank you. Okay, I missed that one.
You.
I can't see. I can't see. I can see now. Oh, got it. Please, 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 please. Where is it?
There.
Got it!
Alright. That took slightly longer than I needed.
Is this Dragon Ball all of a sudden?
Yes.
Oh, you managed to survive
Go
that.
eat the star bits.
Yes, those things. Alright, so that was
Not the bitcoins.
So that was
Not
this galaxy
the
3
Puyos
times in a
either.
row! So that was this galaxy 3 times in a row!
Whee.
Yikes.
Yes! I hope you enjoyed it, 'cause
I didn't.
Now the question is the Prankster comic gonna show up on
Alright,
that galaxy?
The other class I took, alright? Languages and Automata.
What about Automata?
Basically how to determine strings, stuff like that.
Huh.
Okay.
It's like, oh, we have this sort of language we want, it accepts all these strings, make a machine that accepts all these strings.
Oh.
Is this language. And then it's like, okay, and it's like, it starts off on like, okay, so this is a regular language. You can make a machine like this. Easy peasy, right? So what about languages that you can't use machines for? Well, we have this thing called grammars. And grammars, you can make them like this so they have production, so you can make any type of language you want. But what if you can't make it with grammars? Then we got something else!
Yep.
Alright, and then we can now we can make every single language you can ever possibly think of. But what about the languages you can't think of?
Yep.
Well, you're fucked!
Yep.
Oh, we're here already.
Oh, yeah.
Oh dear. That is all the galaxies, huh?
I guess so.
They're all done.
Zoom out, please. Mario. I guess that means this is over then, huh?
Well, I mean, if you want to finish this thing today.
No,
No?
that's
Oh, you don't want to go murder Bowser again?
no, that is an incorrect notion. I'll just talk about languages and automata. It is the most mind-numbing thing ever. Like I said, it starts off okay, and then it goes into stuff that's less okay, and then by the end you're dealing with Turing machines that can compute languages such as A to the N, B to the N, C to the N, where N is the same for all of them, and it's greater than or equal to 0. Yes, that happens. That happens. It is a not okay thing to make a man do, but they do it anyway. And you guys haven't heard of this yet, have you?
Nope.
No.
Okay. Have you seen it at least when looking for classes?
Nope.
Probably not.
Have you checked your graduation requirements?
I'm...
For Foothill, yeah, and that's not on it.
it's
Like,
probably...
there's one for the college and then one for your major, usually. And you have to do both because fuck you.
Yeah, of course.
Well, I can graduate for my major once I finish the classes I'm taking.
Yeah, because my major's like...
And then I get to go transfer, sort of,
Yeah, because my major...
officially, sort of unofficially.
Yeah, because my major is like, oh, you have to take... My major is like, oh, you have to take all of these classes, you have to take all these lower div classes, and then you have to take these upper div classes, and then you have to take these unrelated science general electives for classes you don't give a shit about.
And you had to take general engineering physics.
And then you have to take an ethics class. Oh
Yeah.
boy.
Yeah.
You got to take
And
15
last but-
credits of humanities.
And then last but not least, you have to take a couple units of computer science elective classes.
Yep.
I've already dealt with sociology for one term.
Sociology, yeah.
Because that's one of the required things I had to do.
Yeah, but in terms of like going from master's or PhD, I've been thinking about either getting into security or machine learning.
Oh, that's an option for
Yeah, I think there's like a math class
Support
for
stuff
machine learning at my college.
Bellevue.
Yeah. Like I want to do security because it's
There's also security.
security
too.
because security is great and is very interesting to me, right? But at the same
You got to do lots of equivalence classes.
yes,
I just learned that like
cryptography
less
is
than a week ago in
Cryptogra-
discrete math.
Cryptography is a wonderful thing that will never go away, even if you want it to go away,
Yep.
because it'll never go
And
away.
quantum computing is gonna make it insane.
Yeah, if we can get quantum computing to work,
Oh, yeah.
that's the hard part right now.
Make
Yeah.
it feasible.
Yeah. And but like machine learning is like the hot new thing that everyone wants to do forever. But it's so boring. Like you know how
Genetic algorithms.
you know how machine learning works, right? You babysit an algorithm
Yeah.
to make algorithms that gets taught by an algorithm to be a good algorithm, and if it doesn't be a good algorithm, it dies.
Yep.
It's basically the Hunger Game for algorithms.
It's the algorithm games.
Yes.
Yeah, for genetic algorithms, it basically does natural selection
So like,
for algorithms.
so basically, all you're ever doing as the human duder who is doing all of this, all
Making
you're
sure it
doing
can
is stats.
is
And
statistics,
stats,
yes.
Stats is the worst thing, as voted by the council.
What
Random.
council?
The Council of Random.
Council of Random. So yes, machine learning is boring as hell, even though everyone wants it because it's probably going to be the future of stuff. Who knows? But
Maybe.
speaking of quantum physics, quantum computing, quantum anything really. Speaking of that, I gotta watch a video for no reason about the 10 dimensions of the world.
10
Oh, no.
dimensions.
Yes. So how many dimensions do you think there are?
I thought there
At
was like
least four.
Yeah, the idea is that
3 space, 1 time, and then there must clearly there must be 6 other.
Yeah, what are the other
Things.
6?
the other 6, I don't remember most of them, but the 5th one is basically every possible timeline ever.
Okay.
Huh.
Basically every time, so you know the idea of like every choice you make creates another universe.
Yeah.
Yeah.
That's the 5th dimension, basically.
So,
With the directions yes or no, I guess. Like the ideas behind making a new dimension is that you have to have another direction that's orthogonal to the current dimension, right? And there has to be 2 of them going in one way or the other. And there's also this idea that if you make a fold in an upper dimension, you can connect 2 places in the lower dimension immediately.
huh.
It is so weird.
Sounds it.
And there's ideas like the Mobius strip. If you take a
Oh yeah, the Mobius
yeah,
strip.
if you go along the Mobius strip, you feel like you're going through a loop, but it's actually a thing in 3D, right?
Yeah.
If you were 2D, you feel like you're going in a straight line, but you actually move something in 3D. So you have to think about something like that when you're
Yes.
making a new
But with
dimension.
time.
Yes.
And with time. Yes.
So yeah, so 5th dimension is basically all possible universes, basically. And so the 6th dimension would have to. And so basically, the 6th dimension would have to be something where if you make a fold in the 6th dimension, you can connect 2 points in the 5th dimension for.
Huh.
So it's the space. It's the collection.
So the 6th dimension would consolidate the timelines.
Something like that. Like if you imagine the 5th dimension as a line, the 6th dimension would be a cube of all possible realities.
Huh.
Imagine which one is the line.
If you imagine the 5th dimension as a line,
Then the cube of that would be.
then the 6th dimension would be the cube of possible timelines in the 4th dimension.
Yep.
You see how this is all the way
Yep,
around?
yep.
Yeah.
That sounds lovely.
And I forget 7 to 9. Well,
That sounds mind fucky.
I believe 9 is the direction of information.
Huh.
So that's basically what information is. Like if you take carbon, right?
Yeah.
If you just arrange carbon one way, it becomes graphite.
Yeah.
Arrange it another way, it becomes a diamond.
Yep.
Okay.
Right? Basically, what determines graphite versus diamond is what we call information.
Okay.
Yeah, that makes sense.
Okay.
I might be confusing it with the 8th dimension, by the way.
Oh.
One of them is information. I think it is the 9th dimension because I believe the 8th dimension has to do something about different possible realities, based on if you imagine our universe, right?
But with the different laws of physics.
Yes, basically
Yeah.
different levels of
Okay.
physics. I think that's the 8th dimension. The 9th dimension would be the determination of information, right? And then the 10th dimension would be imagining the 9th dimension as a point, basically.
Oh no.
Oh god.
So,
Oh, no.
So basically, we don't even know. So basically, we don't even know what's in the 10th dimension, other than it's outside the
It's
9th
just
dimension.
too hard.
Because the 9th dimension, is
So-
literally everything. The literally everything that you can imagine. Like this is where the otaku can come from, or some shit like that. I have no idea, right?
Yep, this is starting to sound like Omega cardinality
Yes,
of
you were an
sets.
elf in a past lifetime, in some
Bigger
other
than
place in the
infinity.
9th dimension. Yes.
Omega 0. Then you have Omega 1, so it's bigger than infinity. And then you have Omega Infinity. That's infinitely bigger than infinity.
Yes.
And you can still go bigger.
So the only reason we have a 10th dimension is to imagine something that exists outside of a 9th dimension. Is basically all that exists.
And of course, you can take that to infinity if you
And
want.
the whole reason why the 10 dimensions exist is because string theory relies on 10 dimensions
Yep.
in order
Oh.
to work.
Damn.
Yeah.
Oh, string theory.
Yeah. So that's it. I'm sure we boggled our mind and our brains don't work anymore. So why don't we just quit right now while we're ahead?
Yeah,
we're-
then we can make our non-working brains not work even more with Puyo Puyo Tetris.
Yeah, that'll go well.
Yes.
Yeah, let's stop this insanity.
Goodbye.